Ground under western Montana occasionally rumbles and shakes. Using 3D technology, I continue the deep dive into earthquakes and how they are detected and measured. Earthquakes are fairly common across western Montana, with an average of 10 occurring per day. What underground features make our region so seismically active? I met with Mike Stickney, director of the Earthquake Studies Office for the Montana Bureau of Mines and Geology, to uncover the answers.
These occur in a belt that extends from northwest Montana down to the southeast to Yellowstone National Park. This is the northern part of what's known as the intermountain seismic belt. It's a belt of seismic activity that runs through Montana, southward down along the Idaho-Wyoming border, down through Utah along the Wasatch Front, all the way to southern Nevada.
Within this belt of earthquake activity, there are many different faults, all responding to the gradual stretching of the crust in our region. In Montana, active mapping and LiDAR data have helped to uncover approximately 80 potential active faults. Infrequently, the earthquakes are large enough that we can feel the shaking, though most are too small for anyone to notice. However, they do not go completely unnoticed, thanks to the work of scientists around the world.
The standard method for determining when and where an earthquake occurred and how big it is by measuring the seismic waves that those earthquakes produce by groups of sensors known as seismographs. They consist of a sensor that's buried in the ground that can detect tiny movements.
By measuring the exact time the S and P seismic waves arrive at each sensor, scientists can triangulate that data back to the wave's origin as well as its depth that it triggered. The location at the surface where the earthquake occurs is known as the epicenter, and the area below the ground where it occurs is known as the hypocenter. The amplitude or height of the waves on a seismograph's readings help measure the size or strength of an earthquake. Earthquakes are measured on what is known as the Richter scale. It's a scale that goes from 0 to 10. Most earthquakes in western Montana are less than 2.5 in magnitude, but when we get those over 3.0 in magnitude, we can start to feel them. Moderate property damage often sets in with earthquakes at or above a 5.0 magnitude. Significant to extensive damage occurs for earthquakes exceeding 6.0 or greater magnitude. The world averages about 140 quakes of this intensity per year. Most of those still fall between 6.0 and 6.9. The energy released by earthquakes does not go up in a steady line for every 1.0 increase in magnitude. It's more of a logarithmic scale. For example, a 5.0 magnitude earthquake releases 31.6 times the amount of energy as a 4.0 earthquake. Take a 6.0 earthquake, and that increases by a factor of 1,000 as compared to that 4.0 earthquake. As for Montana, the largest earthquake in state history was
a magnitude 7.3 that occurred down at Hebgen Lake, just northwest of West Yellowstone, back in 1959.
Montana's past, present, and future are all influenced by the tumultuous shaking of the earth. It is something we will have to be prepared for in the future. Reporting from Old Faithful in Yellowstone National Park, Mitchel Coombs, NBC Montana.